So last lesson we looked at the unit circle and its connection to the trig graphs. So remember, our x-axis was basically our cosine that made our cosine function if we tracked the horizontal height, and if we are tracking the vertical height, right, that was our sine. So just to remind you, let's go back and see what happens as our particle, let's say we start here, it's moving around the circle. How does that make our cosine graph and sine graph? Our good old friends at GeoGebra made this cute little animation. So if we look at this point P, imagine as it is moving anti-clockwise around the circle, right? At this point here, how high is it? And it's starting down here. You can see this has got a height, right, of 0 if we're going to measure our height that way. Now, as this moves around, right, so it's going around here, around and around and around, you can see its height, right, its vertical height is getting bigger and bigger and bigger. And so when it gets to 90 degrees, it has a maximum vertical height of 1. After it passes 1, I don't know if you can see that I'm drawing on here or not. After it passes 1, the vertical height, right, starts decreasing. So we'll just play that so you can see what I'm on about. So as this particle is going to move anti-clockwise around the circle, note what the graph does. So you can see it's going up. We'll just again pause that for a minute. Okay, so when it was down here at its minimum, that's this point here. So if I move that point P backwards, all right, you can see that it's going there. As I'm moving it further around, you can see it's now going to come up to, the vertical height is getting smaller and smaller and smaller until it gets to 0, right? So here it's 0, and that's because it's actually come around a whole circle, in other words, 360 degrees. And that just keeps on going and going and going. So if I start that again, it just goes and goes and goes and goes. Okay, so that is my vertical height. Now, if I'm looking at my horizontal height, again at 1, 0, my horizontal height, my vertical horizontal height is 1. But as I move anti-clockwise around, it starts getting closer and closer and closer to 0, right? And guess what? That, people, is going to be our cosine graph. So let's have a look. Oops. Get rid of the sine, right? You can see it's going to start coming when it hits to 0 in a minute. You'll see, let it go one more lap. Okay, here it comes from 0. It starts up at 1, then it's decreasing, increasing, and so on. And it keeps on going. It's an eternal wave. It keeps on going and going and going. So knowing that, we're going to try and tie everything together to help us solve some basic equations, okay? The equation of any unit circle, right, is x squared plus y squared equals 1, and that's because, if you recall from last year, we've got the general form of an equation, or the center radius form, I should say, of the equation of a circle is this, and this is when it has center AB and a radius of r. Now, with our unit circle, our center is 0, 0, and we've got a radius here of 1. So x take a, in our case a is 0, so x take 0 is just x, and we square it. So that's how we get x squared plus y squared. How is this now connected to this? This is one of the important identities that you're going to use quite a lot, and those who are doing spec maths, you're going to use that even more than the rest of us. Because as we said before, our x-axis is actually the same as our cosine, so that's why that becomes cos x squared, and then our sine is our y-axis, and that's why that is now sine squared, and of course the radius is still 1. All right, another important property here, tan theta equals sine over cosine. Handy to know. A couple of other things, just housekeeping details. Is when we're talking about angles, we go in an anti-clockwise direction, as you have noticed when we marked the unit circle last time. Okay, so it's a simple matter of, if I'm going 30 degrees, right, 30 degrees goes that way, 60 degrees, right, we're going around like so. if I wanted to work in pi, instead of 60 degrees, that would be pi on 3 radians. If I go this way, this angle here, which would be symmetrical, that would actually be minus 30 degrees. Or 360, take 30, 330. So those are equivalent angles. Okay. And it means that you can do laps and laps and laps. So if we think of 30 degrees here, what is another equivalent angle for that? So if we think of our unit circle, or just a circle, and we're going around, 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 Buffalo Girls go around the outside, around the outside. So here's 30, right? If I do one whole lap and go around again, I've lapped another 360. So 360 plus 30, 390. So that 390 is equivalent. Okay, so basically you can keep adding on 360. If I go the other way and I take off 360, right, 30 take 360, I could also have minus, right, 330. Bit silly, but same deal. Okay, that would be now minus around the other way, and that would be minus 330. Okay, hope that makes sense to you. What about 300 degrees? Okay, there's my, that's a better looking circle. There's my, so whereabouts would 300 be? Remember, this is 270. This would be 360, so 300 would be around here. Okay, but that just happens to also be minus 60 degrees from 360. So minus 60 degrees is the equivalent spot on the unit circle. Okay, so hopefully things are starting to connect with all of these and pulling them together. Okay, so we graduate to a question like this. Find the possible exact values for cos theta if sine theta is 2/3. Now you can see this is one of the ways that your textbook is looking at it, and they're using that identity that we explained right at the start, right? That came from equation of a circle, x squared plus y squared equals 1, but our x is cos squared, our y squared is sine squared. Okay, so that's how we get that. And you can see very easily here, they've just substituted, right? 2/3 sine, they've substituted in and rearranged. How that relates to our unit circle, right? As you can see, now when we've got sine of 2/3, so let's put 2/3, that's it there. Remember, we can see that we've got two possible solutions for whatever cos can be, right? That's your cos value there. I like to do it using a good old triangle. Okay, so bear with me and then you can see which method you prefer. I have no problem if you want to do cos squared plus sine squared. It's handy. Sometimes I do that as well. Now, think back to your olden days. Remember, we know that sine theta is opposite over hypotenuse. Okay, so when we're talking that our sine theta is 2/3, this is my angle, my opposite is 2, and my hypotenuse is 3. Using basic Pythag, right, we know that this length here is going to be square root 3 squared minus 2 squared, which will be root 5. Right, 9 take 4, 5. So now I can easily tell you what cos theta is, because remember, cos theta is adjacent over hypotenuse. So here's my adjacent side, which is root 5, all over 3. And I just find that's really easy, especially if the question had gone on and even asked you to find tan theta, right? Because we know tan theta is opposite over adjacent. So opposite over adjacent, so 2 over root 5. And we don't like square roots at the bottom, so times by root 5, top and the bottom, so that's 2 root 5 on 5. Your calc will do that for you. Okay, what about all this plus or minus stuff? Well, if you think about when we're saying here that sine theta is positive 2/3. Sort of already does it in the diagram up there, but I don't even draw the circle. I don't bother about all the other bits and pieces. I know that sine, remember sine is your y-axis, and sine is positive in these upstairs quadrants, right? So in quadrants 1 and 2. Now, what is cos theta in these quadrants? Well, cos is positive on this side, right? But it is negative on this side, so therefore definitely will be plus or minus. And similarly with tan, it will also be plus or minus. Okay, I know I've got that little, that should be an equal sign there. Okay, and again, you might think, I don't know, sort of a much of a muchness, but when we come and do another question like so, I think it's even better, because you can see here we've got cos and tan. Now, if you look at the example, right, hopefully it's easy to follow. Okay, we've got, then used our cos squared plus sine squared again, and so you substitute in the sine theta for -3/4. That's how we, so -3/4, square the top, square the bottom. That's how we get 9/16. And how do we get rid of a plus 9/16? You take, so right, straightforward calculations. Okay. And we've got our cos theta. Then we have to look at what quadrant it's in to decide if it's plus or minus. Okay, and because it's in quadrant 3, cosine must be negative. It cannot be positive, it's only negative. Then it's asking you to find tan, and they're using the property that tan is sine over cosine. So you've got to divide some fractions and away you go. And again, in this quadrant, tan is only positive. Haha. So absolutely, you can do it that way. Let's just go back and suss the good old triangle. Gotta love a triangle. So how do we do it with the triangle? Well, I'm glad you asked. Once again, we draw our triangle here, and I'm going to ignore the negative, right? Ignore it. So once again, sine theta is opposite over hypotenuse. Do a little bit of Pythag. So we've got 16, 4 squared minus 3 squared, which is 9. And so that's how we get √7. And here we go. We're going to find cos theta. So if we're looking at our triangle, cos theta is adjacent over hypotenuse. So that's going to be √7 over 4. Tan theta is opposite over adjacent. So that is now, let's get rid of that one, that is now opposite over adjacent. So that's 3 over √7. And remember politeness in maths world. So get rid of that √7 from the bottom. We times the denominator by √7 and therefore times the top by √7. So we get 3 √7 over 7. You're not done, because we now have to deal with, right, this bit here. And similarly to the example that they had in the textbook, but I don't even draw the whole triangle. I don't even draw the whole circle. I get mixing my shapes here. I look at this and I go, okay, remember this was 0. Oops. This was 0. This is 90 degrees, aka, otherwise known as pi on 2. This is 180 degrees, also known as pi. And 370 degrees, which is 3 pi on 2 radians, and we come all the way back to 2 pi. So from that diagram that we saw, if we're looking at this, it's in this quadrant here, so quadrant 3. And now we're asking ourselves, okay, in this quadrant, what is the sign of cosine? So remember, cosine is your x-axis. So on this side, it will be negative. It cannot be positive. And for tan, right, in this quadrant, sine is negative, cosine is negative, and negative divided by negative is a positive. So you don't write positive, but I'm just putting it there to make a point. I hope we like that. Let's try another one. Okay, so you know the drill. You don't have to listen to this if you know what's going on. So find the possible exact values of cos theta for these. So again, by all means, feel free to use sine squared plus cosine squared, but I'm going with, we actually did this in class the other day, but just proves a point. So we've got our angle there. Sine theta is opposite over hypotenuse, so 2 squared, take 1 squared is root 3. Therefore, cos theta is adjacent, right? Adjacent over hypotenuse, so we've got root 3 on 2. And in our case here, if we're looking at our quadrant, do it underneath, okay? If we're looking at our quadrant here, in which quadrant is sine positive, right? That's a positive value. Where's it positive? So sine is positive in these quadrants, right? And cosine is positive here, so cosine positive. And this way, cosine is negative. So therefore, for those shaded areas, those regions, quadrant 1 and 2, cosine could be positive or negative. That's it. Right, let's try the next one. So sine theta is a third. Now, once again, I'm going to ignore the negative there, right? Ignoring. Don't look at it. We're going to say it's 1 over 3. Again, Pythag, 9 squared, take 1 squared is root 8, which we know to be 2 root 2. So therefore, cos theta is adjacent over hypotenuse, so 2 root 2 over 3. Once again, we suss our quadrant, right? Where now we're going to look at that negative, okay? So where is sine negative? Well, this time downstairs it's negative, right? Remember, your sine is like your y-axis, so we know y is negative downstairs. And once again, cosine in this quadrant is positive, and cosine in this quadrant is negative. So we can plop in our positive and negative there. And just when you think, hey, this is all groovy, it's working out, I understand, we get 0. How am I meant to draw a triangle for that? Well, that's what we have to think about. It's actually a special case on the unit circle. Okay. So here's our unit circle. A dodgy looking circle if you ask me, but anyway, we'll take it. So when is sine theta 1? Now remember, sine theta is your vertical height. So when is it 0? Well, it's 0 here, and it is 0 here. So this is the point, right? 1, 0, and this is the point, negative 1, 0. Okay, recall, so when it's all starting to come together, right? Cos theta, any point on the unit circle is cos theta, sine theta. So when sine is 0, cos can be 1. But we've also got the situation, this one, where sine is 0 and cos will be minus 1. So once again, we've got two solutions. So we can say, therefore, when sine theta is equal to 0, cos theta can equal plus or minus 1. And you might be thinking, well, this is just going to be plus or minus every single time. So for part D, the hell make the point that not always. So once again, basically for values of 0 or plus or minus 1 for sine theta and cos theta, go back to your unit circle. Okay, so when is sine theta equal to minus 1? So remember, that's your y-axis, right? Only one point this time, 0, minus 1. So here, that's our sine. This is our cosine. So sine theta equals minus 1 when cos theta is 0. Hope that makes sense to you. This is becoming a little bit of a long video, but hang in there. So question 2 is pretty much what we just did, but now you're using cos theta instead of sine theta. So when you do your triangle, instead of starting with opposite over hypotenuse, you will start with adjacent over hypotenuse and then use Pythagoras to get the opposite. All right. Okay, so question 3, basically exactly the same thing that we were doing before. but now they're giving you the specific quadrant that you have to look at. So if you had trouble with question 2, pretty much the same as this, because now we've got cos theta, right? So you put theta this time, cos is 2/3, so adjacent over hypotenuse. 3 squared take 2 squared, right, is root, well, it's 5, but then you have to square root it. So there we go. That means, therefore, sine theta is opposite over hypotenuse. So it's going to be root 5 on 3, but now we have to decide, is it positive, is it negative, or can it be both? So it's a simple, let's have a look at our quadrant here. And what are we talking about when we're going 0 to pi on 2? So here's 0, here's pi on 2. So we're definitely talking about this quadrant. And in that quadrant, sine can only be positive. Okay, so we leave it as it is. Just do one more before we send you on your merry way. You're probably going to go, I've got it now, I don't need the video. Heard enough of her. Okay, sine theta is 2 opposite over hypotenuse. Okay, 25 take 2 squared. Do I have to write that down? 5 squared take 2 squared is root 21. Therefore, right, we're trying to find cos theta. Therefore, cos theta, which we know is adjacent over hypotenuse, so that's going to be root 21 over 5. But now let's check our quadrant. And this time, what are we looking at? We're looking between pi on 2 and pi. So quadrant 2, 2, 2, 2, 2. Now in this quadrant, right, cos theta, I should not say theta, remember, cos is your x-axis. So in this quadrant, it can only be negative. So bang. So you cannot put positive or negative. You cannot just put positive. You've got to make sure that it's negative root 21 on 5. It's not close enough is good enough. Okay, so hopefully you're okay with that and you can progress. When they're looking at this example here, again, I go, no. Use your triangle again, because you're going to do exactly the same thing to find tan, right? Again, if I asked you to find tan for this one, it hasn't asked you to, but let's say it did. Tan is opposite over adjacent, so 2 over root 21. You'll be polite. I'm doing this without a calculator, and you can too, but if you really don't want to, then whack that into your calculator and it will tell you that it's 2 root 21 over 21. Right, we go back up to our quadrant and we go in quadrant 2, what's the sign of tan? Now, sine is positive, but cos is negative, so a positive over a negative equals a negative, so that would have to be negative. That's the gist, right? So that main concept, and just sort of tweaks it a little bit, but I think you can do it. Good luck.